everyone, it's Justin again. Mia and I are on our way to Dinosaur National Monument. We've got 260 miles to drive today and 4 stops equally spaced along the way. Our stops will be the wildlife viewing area, the river rest stop, the visitor center, and Dinosaur National Monument. In our last lesson, we learned how to divide large numbers like this using the partial quotient strategy. And today we'll learn another strategy that can help. By the end of today's lesson, you'll be able to use your knowledge of division, multiplication, and subtraction to solve multi-digit division problems using the long division algorithm. Have your guided notes ready? And let's get cruising. The long division algorithm is a step-by-step process used to divide large numbers into smaller groups or parts. It follows the same steps no matter how big the numbers are. We can give it a try with our drive today. There are 4 stops equally spaced along a 260-mile drive. How many miles apart are they? We'll set up our problem using the long division symbol. The dividend, or the total amount being divided, 260, goes inside the symbol. And the divisor, the number we're dividing by, 4, goes here to the left of the symbol. We'll place our answer, the quotient, in this space above the symbol. Now, instead of dividing all of 260 at once, we'll work with it in chunks from left to right. The long division algorithm follows 5 steps: divide, multiply, subtract, bring down, and repeat. For step 1, divide, we ask ourselves how many times the divisor fits into the first digit of the dividend. So, in this case, how many times can 4 fit into 2? It fits 0 times, so we record a 0 in the hundreds place of the quotient. Next is step 2, multiply. We multiply the 0 in the quotient by the divisor, 4. 0 times 4 equals 0, which we'll record under the 2 in the dividend. Then, step 3, subtract. 2 minus 0 equals 2. Step 4 is to bring down the next digit of the dividend. Drawing an arrow is a great way to keep the numbers in line and organized. We'll bring the digit 6 down in line with the 2 we had left over after subtracting. Finally, step 5 is to repeat the steps until all the digits of the dividend have been used. To repeat the steps, we'll check how many times 4 can fit into 26. Well, 4 times 6 equals 24, so 4 fits into 26 6 times. We record the 6 in the quotient above the tens place. Step 2, multiply. Multiply the 6 in the quotient by the divisor, 4. 6 times 4 equals 24, which we'll record under the 26 in the dividend. Then step 3, subtract. 26 minus 24 equals 2. Step 4, bring down the next digit of the dividend in line with the 2 we had left over after subtracting. And step 5, repeat! How many times can 4 fit into 20? It fits 5 times. Record the 5 in the ones place of the quotient. Multiply 5 times 4, which equals 20, and then we subtract. 20 minus 20 equals 0. There are no more digits from the dividend to bring down, and we can't subtract any more groups of 4 from 0. So 260 divided by 4 equals 65. This means that there are 65 equal groups of 4 in 260. And each of our stops are 65 miles apart. Take a moment to think about how the long division algorithm is different from other algorithms you've learned about, like the addition, subtraction, or multiplication algorithms. Pause the video here to record your thinking. The long division algorithm is similar to the other algorithms we've learned, except now we're working from left to right, or from the biggest place value to the smallest place value. I wonder what we'll see when we get to Dinosaur National Monument. Ooh, Mia, check it out. According to the brochure, the Quarry Exhibit Hall has 1,535 fossilized dinosaur bones on display with an equal amount from 5 types of dinosaurs. I wonder how many bones are from each type. If we divide the 1,535 bones by the 5 types of dinosaurs, we can figure it out. Let's set this up with the long division algorithm to solve. Start by drawing the long division symbol, placing the dividend inside and the divisor on the left. Now we'll follow the steps of the long division process. Starting with the largest digit of the dividend, can 5 fit into 1? No, so we'll record a 0 in the thousands place of the quotient. Multiply 0 times 5, that equals 0. Subtract 1 minus 0, which equals 1. Bring down the next digit in the dividend. Now we repeat. Can 5 fit into 15? Yes, 5, 10, 15. It fits 3 times. Place the 3 here as part of the quotient. Multiply 3 times 5, which equals 15. Then subtract 15 minus 15. That equals 0. Bring down the next digit of the dividend. Repeat. Can 5 fit into 3? No, 5 is more than 3, so it fits 0 times. Record the 0 in the quotient. Multiply 0 times 5, which equals 0, and record that to subtract. Pause the video here to continue using the steps of the long division algorithm to finish solving this. 3 minus 0 equals 3. Bring down the last digit of the dividend, 5. Repeat. How many times does 5 fit into 35? It fits 7 times. We record the 7 in the quotient. 7 times 5 equals 35. Then 35 minus 35 equals 0. Since there's nothing left in the dividend to divide, the problem is complete. 1,535 divided by 5 equals 307. Which means that there are 307 bones from each type of dinosaur. The brochure also says that there are 7,002 rock carvings in one area of the monument. There are equal amounts of 6 different types of animals depicted. How many of each type of animal are carved into the rocks? Pause here to use the long division algorithm to solve 7,002 divided by 6 in your guided notes. 6 fits into 7 one time, so we record 1 as part of the quotient. 1 times 6 equals 6, so we subtract 7 minus 6, which equals 1. Bring down the 0, and now we have 10. Repeat! 6 fits into 10 one time. 1 times 6 is 6, so next we subtract 10 minus 6. That equals 4. Bring down the next digit. Repeat! How many times does 6 fit into 40? It fits 6 times. 6 times 6 equals 36. Subtract 40 minus 36, which equals 4. Then bring down the last digit, 2. Repeat! How many times could 6 fit into 42? It fits 7 times. 6 times 7 is 42, and when we subtract 42 minus 42, that equals 0. There are no more digits left in the dividend, so 7,002 divided by 6 equals 1,167. And that means there are 1,167 of each of these 6 types of animals carved into the rocks in that area of the monument. I can't wait to see those ancient carvings. So, what have we learned today, besides the fact that some amazing fossils are waiting for us? Well, now you know that large division problems can be solved step by step using the long division algorithm, which uses division, multiplication, and subtraction to break problems into smaller, more manageable chunks. Be sure to complete the practice questions and extension activities that go with this lesson to practice the long division algorithm. And remember, mathematicians, in math, As in life, every effort adds to your success. I'll see you next time.